Now, you have a 5G research lab that you head up, is that right?
Yes.
So I think that you've discussed sort of 4 different tracks within 5G research, and I was hoping that we could just touch briefly on each of those, starting with the silicon.
Okay, so if you look at any wireless system, it is always a thing about building the right hardware. So silicon, antenna subsystems, whatever, all packaging of this whole thing. So there's a whole hardware aspect to it. So we have a hardware track in the 5G Lab Germany, where I have all kinds of faculty join the 5G Lab Germany to design or to tackle the challenges of some of the 5G hardware. Then obviously the next thing is to look at the wireless track, because the next thing that you have to do is get the bits over the air and see how you build a wireless system, the wireless infrastructure, the wireless networking side. That's the next part. And then once you have the radio access network done, you get into the core network. That's what you classically call that part, which now merges with mobile edge cloud. Yeah. So it's a mobile edge cloud core business, because we cannot have the cloud computer sitting somewhere far away. It has to be close by for the short reaction times. And because the amount of data is just also too big to move it back and forth all over the place. And so that's the third track. And the fourth track is then verticals. So tactile internet applications, looking at these vertical industries, understanding them. So like I'm working with a mechanical engineering colleague of mine that does machines for harvesters, for the big corn harvesters and things like that. So it's interesting to see how you can get into these different areas. And I think with 5G, it is not a communications deal alone. It is really going to go into the verticals. And so that's fun to touch it all the way to there.
So that obviously informs the Internet of Things, the verticals that you're talking about.
Yes, the Internet of Things is, however, obviously also not only in a network for the tactile internet, for the remote control, for the short reaction time, for really driving whatever, a harvester over a field or whatever all. It is also connecting billions, maybe even trillion of devices into the network and just blipping a couple bits here and there. So think of it this way. Now it's winter time. Snow is falling. Yes, you want to go skiing. So you go skiing, and your skis obviously should have an IoT device in it, because then you can track the skis if somebody accidentally takes them.
If you lose them, whenever
if you lose them, because you're in the powder and they're somewhere, you can actually tell the ski, give me a hint where I can start looking for you. And while you're on the slope, they're tracking and they're finding out there's powder here, there's ice there. So if you feel like moguls, all these skis talk to each other, build a social network, a thing book, I call it, not a Facebook, because not faces, but are things that are being connected, and a community. And then if I feel like racing, I know exactly from this information, I'm looking for ice at this slope, steepness. I can go there. If I want to do moguls, I go there. Powder is there, and this kind of thing. But then you put these skis into your cellar for 12 months almost, don't touch them, and they go into deep sleep mode. So these are objects that on average only need to send a packet every 100 seconds, on average over a year.